In this episode, a look at making liquid metal electronics and Nissan's solid oxide fuel cell. Welcome to your Manufacturing Minute. Mention the words liquid metal and your mind will probably wander into the realm of science fiction. But in reality, metallic elements with low melting points, like mercury and gallium, have long been able to be poured like just about any other liquid. And a new study by Australian researchers suggests that flexible gallium alloys could be used to make everything from on-demand 3D displays to floating electronics. Engineers from RMIT University in Melbourne immersed droplets of non-toxic gallium alloys in water, then changed the water's chemistry to make the droplets move and change shape without external stimulants. Such self-propelling liquid metals are malleable but also have a highly conductive core. They're also coated with a thin semiconducting shell, which could enable the use of flexible soft circuit systems in electronics. They could eventually move autonomously and communicate to form new circuits altogether, revolutionizing everything from electronics to engineering to medicine. In what ways could industry benefit from next-generation flexible metals? Tell us what you think by leaving your comments below.
Although auto companies like Nissan have embraced electric power, range anxiety and charge time fears have slowed its adoption rate among consumers, meaning EVs have a way to go before they're a viable alternative to traditional internal combustion engines. That's why fuel cells may hold an advantage. Nissan is now testing a fuel cell electric vehicle named the ENV200, which boasts a range of around 373 miles, compared to EV's current cap around 311 miles under ideal conditions. Using a solid oxide fuel cell announced in June, Nissan is demonstrating the prototype in Brazil as part of its intelligent mobility strategy. The 5 kilowatt solid oxide fuel cell is slotted into the floor pan and draws on an 8-gallon tank of ethanol blended water. Using a reformer, it converts this blend into hydrogen, which is mixed with atmospheric air and converted into electricity to charge the vehicle's battery. Doing things this way has a few benefits because whereas fueling a pure hydrogen car involves pressurized tanks and a locking nozzle, the solid oxide fuel cell can be fueled using existing infrastructure. Compared to a pure EV, a system like Nissan's also means drivers are able to maintain their existing fueling habits rather than having to wait long periods of time for the battery to charge. Will this lead to better ranges and adoption of alternative fuel vehicles? Tell us what you think by leaving your comments below. Well, that's all the time we have for today, but tune in every Tuesday and Thursday for your next Manufacturing Minute.